Interaction. Actually, I skipped that chapter about the interaction part. Interaction is the multiplication term. So female and education, multiplication. So that's what we call the interaction. So interaction term is the when we have for example, education doesn't have any effect on the wage. However, that works. So this is like that when you hire give a wage to the man, you don't care about what education that man has. Okay, so high school drop off or uh, master degree, we don't care. So education doesn't work on the man. But when we hire female, then we give a wage a lot differently, depends on the education. Yeah, of course, in really that's not true, but let's assume that kind of the situation. Then how can I get a effect of education? Maybe still you can get some the number here, the coefficient of education, but that is not the exact the model. So when the education work with a female uh, differently than with a man, then this one will have a significant number. So statistically significant. If this is a significant, that means education effect differently. So here differently is with the female, right? So education will have an effect on the wage, but when it is a male, there is an effect. But when it's a female, the effect will be the different. Uh, that's the what it means is this one is the significant or greater than or so it's not equal to 0. But if this is like a 0, so we cannot reject the null hypothesis. Then we can say the maybe education just work for man and woman the same way. Okay, so the interesting hypothesis is this is a 0 or not. You can say the education is the same for the man or not. So if it's a 0, that means education works same for man and woman. And if this is not 0, then this education works differently with a man and woman. Or you can have these two hypothesis is this is the female, this is female part, and this is the female and education interaction. So in that case, it's a female doesn't have any effect on the wage at all. The whole wage education is same for the man and woman. So we cannot. It doesn't. Why this is if this is a 0, then you can see okay, female doesn't have an effect, but education related female has something else. Then we cannot say the female doesn't have any effect, right? However, if both of them are 0, then there's nothing on the female in this equation. So we can say a female doesn't have any effect on the wage if this null hypothesis is true. So we can test this null hypothesis. Our data clearly shows a different data. So we have a low p-value, then we can reject the null hypothesis. Graphical illustration. This is also like this. This 0 means less than 0 means this point. Okay. This is about the female. This is the coefficient of the female, which means this is like a starting point. Without considering any education or the tenure and whatever, we ignored all of them, then what is the difference between female and male? So this one is showing the what is the difference between this man and woman. It's going up on the education, but what is this coefficient means is how they affect the education, because this is for the female times education, right? So what is the effect on the education with the female? So this is a smaller than 0 means actually we have a lower slope. So this slope is and this slope. Let's say this slope is s, then this slope is the s minus something. Okay, and this case is still this part is negative means, right? This is this part. Actually, this difference is this one. So it's a woman has a smaller starting point, but this is the greater, which means that this slope will be greater than, because this is greater than 1. This slope is greater than this one. Okay. But if we say this coefficient of the interaction is the 0, then effect of education is same for the man and woman. So there's education has a working. It's the same effect on the wage with a man and woman. So if you run the regression, actually you can find the p-value and you can tell what is the effect here. So let's do that on R. Okay, I will bring the data wage 1 from package would reach, right? So we got a wage 1, and then we will do the linear regression. Linear model and the wage. We will use a log wage. Female education, experience scale, tenure scale. Okay. Female plus education plus female times education. Actually, you can just try to multiply here, multiplication, but then it will treat this one as a female times education, vector times vector. So you can multiply each of them together. Right? So you can leave it there, so that's fine. But basically, how the R treated this variable here is this is a vector, this is like a vector, all numbers here. So you have to be careful. And then what was that? What was the other thing was experience plus experience square. Here you can, if you type the experience experience square, then it will not. It has a problem because you cannot do the square the vector with the vector. So if you really want to include the experience square here, then you have to use a I function. This is like a let me show you here the topic is the I. Not here, right? I is like a as is, right? So you are not handling this. I means you calculated inside, right? Each individual things and then take a whole things again. That's what it means is I. If you don't use I function here, it will consider like a vector times vector, so it's not gonna be square. It's gonna be a problem. So I'm gonna use and then what was the tenure? Tenure plus again tenure square. So whenever you have a like a little complicated calculation here, then you better use I function. So now I did it, and then summary of LR. So you don't have to use LR, and you can use anything. So you can have all coefficient here, right? However, if you look at the p-value, this female has like a high p-value, it's like a 17.6%, and also female education also has like a 67%. So this is the pretty high p-value, so you cannot reject, you cannot say this is not zero. This one, maybe you can get this number, even though null hypothesis is true, still the probability to getting this number is 17.6%. That's pretty high. And this one is like a 67%. Okay, that's what here we can see here. There is no significant evidence saying this is not zero. Null hypothesis, this is a zero. Is I forgot, this is the beta 1 equals 0. But our p-value is like a 17.6%. So what is the probability that if this is true, we get this number is like a 17%. So we cannot say this is a rare case, so we cannot reject the null hypothesis. The same thing here. Our null hypothesis is that this is beta 1, beta 2, beta 3. And then probability is the 67%. Which means probably this is 0, even though this is true, still we can get this number. The chance is 67%, so we cannot say this is not 0. So no evidence, strong evidence against the hypothesis. So the hypothesis is the education is work same for the woman and man, but we don't have a strong evidence to reject that. So does it mean that there is no significant evidence of low pay of the woman? This is only effect for the education is 0. So we have to look at what if if the education is greater. To answer this question, actually you have to recenter the interaction term, which is the average 12.5, which means actually we have to instead of this term we have to replace with the female times education minus 12.5. So we will talk about it later, the later slide. If you change it and then run the regression again, and then you have to look at the coefficient. So we will talk about it that later in the policy or the program evaluation.